Hello, good morning to all. My name is Dr. Muniratnama LM, Assistant Professor, Sri Kalavara Varadarajam Shetty, Government First Grade College, Koteshwara, Kundapuram, Udupi District. In this session, number 11, I am going to explain the difference in wavelength between two neighboring lines with the help of Michelson interferometer. The learning objective of this study is determination of wavelength of monochromatic light and difference in wavelength between two neighboring lines using Michelson interferometer. The main outcome of this study is to understand the concept of wavelength and difference in wavelength using two monochromatic sodium lines. Let lambda 1 lambda 2 be the wavelengths of two lines, that is D1 and D2 of sodium. Each line will produce their own system of fringes. Then with the help of Michelson interferometer, there are two mirrors. M1 is moved and the position is found when the fringes are very bright. If the fringes are very bright, we can get here a longer wavelength of the spectrum. The fringes will be distinct and it is a fringes are in superposition of lines. Then M1, the mirror M1 is moved slowly, the visibility of the fringes is decreases. When the fringe width R it is least, the field of view R it is at maintained constant. This corresponds to the position of maximum distinctiveness, that is M1 is further moved, again the fringes will be well defined in a manner. Let x be the distance moved by the mirror for two consecutive positions of maximum distinctiveness, then the path difference defined by 2x. The path difference between the fringes is 2x. During this condition, let M1 and M1 plus 1 are the changes in the order of the fringes due to lambda 1 and lambda 2. Then you can define here path difference 2x equals m lambda 1 equals m1 plus 1 lambda 2. Then m lambda 1 equate these two conditions. M lambda 1 equals, you can multiply lambda 2 with m plus 1. M lambda 2 plus lambda 2. M equals lambda 2 by lambda 1 minus lambda 2. Substituting m, we get 2x equals lambda 2 by lambda 1 minus lambda 2 into lambda 1. Then the change in wavelength or difference in wavelength, this can be written as delta lambda, that is lambda 2 minus lambda 1 equals lambda 1 lambda 2 divided by 2x. Let lambda 1 lambda 2 are approximately equal to lambda. Here we get lambda 1 lambda 2, that is as lambda square. Then here this is the expression related to this difference in wavelength. With difference in wavelength, this can be calculated with the help of interference Michelson interferometer, that is delta lambda equals lambda square divided by 2x. From this session we have two multiple choice questions, that is the ratio of phase difference to the path difference between the two light waves is 2 pi by lambda. Answer is C. Second one is, if the two sources are said to be coherent, if they have, what is the condition when the two sources are said to be coherent? That is definite phase relationship between two fringes. Finally, the conclusion is, from this session we have derived an expression related to wavelength between two neighboring lines with the help of Michelson interferometer. Then last one is, reference used for this topic is Optics by Ajay Ghatak and Brijlal and Subramaniam. Thank you.